Remember this announcement from April 2024?
I am pleased to announce, after a very thorough and rigorous procurement process, NASA is selecting 3 awardees to provide lunar terrain vehicle services.
Intuitive Machines, Lunar Outpost, and Venturi Astrolab entered into what's called a service contract. That means that they're responsible for not only developing their LTV design, but for figuring out how to get it to the moon. But before any of that happens, though, they had to go through a 12-month feasibility phase leading to their preliminary design review.
During that time, our NASA teams will be working with them to understand what their designs look like, iterating with them on where we can make improvements, and understanding how they incorporate into our overall lunar architecture. Once we get past that point, we will have a follow-on subsequent competitive request for proposal go out. They will then compete for what we call a demonstration task order. That demonstration allows them to finish the development, get the LTV to the moon, and demonstrate it on the surface prior to the arrival of the Artemis 5 crew.
That was a year ago, and we were curious how things were going. At the 40th Space Symposium in Colorado Springs, we got our answer. All 3 competitors had their LTV designs on display for attendees to marvel at. You can tell by looking at each one that the 3 companies and their respective teams came up with very distinct designs. But we wanted to do more than just look. So, we spoke with leaders of each competing company to learn more about their approach to the LTVs, the competition, and what comes next, even if they're not selected. Let's start with a super basic question. How did they come up with their designs?
Early in my career, I was at the Jet Propulsion Laboratory, and I worked on a program called Athlete, which was part of the Constellation program to go to the moon at that time. And Athlete was specifically designed to move large cargo around on the moon. It's going to reposition habitats and set up infrastructure. So I started thinking about this problem, about how do you do last mile logistics on the moon back in those days. So when we started Astrolab 5 years ago, we really set out to solve that problem, especially in the context of NASA's investments in large lunar landers like Blue Moon and Starship. So the original kind of founding idea was thinking ahead to at the time when tens to hundreds of tons of cargo were arriving at the moon. We wanted to build a really versatile and flexible platform to take all that cargo from the lander and deliver it to the point of use.
I would say first and foremost is having great partners. So the team behind us, we've got Boeing, of course, but then we've got Australians, we've got French, we've got car racing companies, we've got universities, we've got companies that work on spacesuits. And so Intuitive Machines, we knew we couldn't do all of that ourselves. We bring surface operations experience, we bring lunar operations experience, communications, power management. We'd bring a lot, but the scope of what we're sitting in is vast, right? And this vehicle is built to work by itself for 5 years on the lunar surface, right?
Yeah.
So we knew it was a big job, and we worked to put together a team of people who've been working on similar projects and brought it all together.
For our lunar terrain vehicle, the Eagle, we really prioritized crew safety, science-forward design, and ease of operation and use for our crew. And so in our testing with NASA astronauts, all suited up in their actual pressurized spaceflight suits, they really liked this wide open cockpit, the large steps, the great handholds. It made them feel very comfortable and safe when they came and sat down in the vehicle and got ready to drive it. Similarly, their feedback is spread throughout the cockpit. It's very clean, very simple to drive, and very intuitive to use. And so, these were things that were very important to us as we went through the process, was to make sure we were focusing on that human factors and crew safety from the very beginning.
That focus on astronaut safety was key among the requirements coming from NASA when each of these providers are coming up with their designs.
Because this is a human-rated vehicle, there are NASA human safety standards of things like, hey, critical switches have to have protectors so that you don't inadvertently activate them or damage them. This is our lights. I'm going to turn the lights off in here, right? But I only want to turn the lights off when I want to turn the lights off. So these switch protectors are important, and they're specified by 60 years of human spaceflight. So it's not just something that looks cool. Emergency power off. You see a protector here.
Every piece that the astronauts will touch or interact with has been designed and scrutinized and learn from the lessons of the past. NASA obviously has great experience in designing systems that are very easy for astronauts to use, very safe and very useful out there in space. And so that's been great, just working with their EHP and human flight operations teams to get this cockpit really dialed in for the crew with their pressurized gloves and exploration suits.
Our partners are amazing because they fill in gaps that we have. A lot of my team came from SpaceX and JPL. We have a lot of experience, particularly on the robotic system side of things, so the more kind of JPL style rover, so to speak. Where we specifically lacked a lot of experience was in human systems interaction. What are the limitations of a suited astronaut? So Axia brings that to the table with their experience with the suit. So they're supporting not only the astronaut interfaces, but all the crew training. And they also, through their contracts, are responsible for all the geologic tools, scientific tools that the crew will have. So on the rover, they're responsible for accommodating those tools. So it's a natural, marriage there. And then our other partners, Odyssey Space Research, long history in human spaceflight software, safety critical software that has to work every time. And so they're providing software to the vehicle.
Part of dialing in their designs involved getting feedback from NASA astronauts at the Johnson Space Center late last year.
So actually behind me here is our human-in-the-loop mock-up. So this is the actual article that we delivered to Johnson Space Center in the fall. And yes, they had astronauts wearing pressurized suits, and they were actually using their Argos gravity offloading system. So they were experiencing 1/6 gravity in spacesuits while they interacted with this system. We provided them the opportunity to drive the rover, actually looking in that direction, so kind of like a ship captain looking, out with the ship in front of them.
Right.
And also the reverse, as we have it configured here. And we did that both on this platform as well as our drivable unit that we have in California. And we actually had crew come out to LA and drive that rover in both configurations. And so there was generally a strong preference for this configuration. So we've now baselined that where the astronauts are driving in this direction. It gives them an unobstructed field of view. And it's, again, about really maximizing the science return ultimately. And so they really appreciated the ability to be able to look around in front of them completely unobstructed, so that if they see an interesting rock, they can drive right to it.
Well, we got to do some really awesome testing with our crew test subjects very early on. One of the tests had two crew members suited up in their actual pressurized suits, working together and doing all of the cooperative activities. That gave us really great insights into things like when both crew members come into the cabin, they need to turn around and sit in these seats. If one needs to help the other, they liked having all of this room in our cockpit and our design. Nice, easy restraints to use, things like that. And then we did another type of testing where we had a single crew member under gravity offload. And so that was really good for evaluating things like the step height into the cabin and just the motions the crew will use as they interact with the vehicle. Similarly, around the outside of the vehicle, the crew really liked the easy accessibility of their tools. We have those in the side-mounted toolboxes as well as the tool racks in back, and our work surfaces that give them a nice, well-lit, stable place to set their tools and do their work.
In addition to current NASA astronauts, Intuitive Machines also called upon the expertise of former Apollo-era astronauts, Charlie Duke and Harrison Schmitt, who were two of the 6 people who have actual experience driving a moon buggy on the lunar surface.
Yeah, so there was a lot of discussion about clearance and grab angles. Hey, I have to be able to grab this, I have to be able to reach this, and visibility, right? How can I maintain good visibility, and what does the sun at a low elevation angle at the moon look like? We're all used to seeing the full moon, wow, the moon's bright. But a lot of times we're going to be operating this vehicle at low solar elevation angles. In fact, we're going to the South Pole. And so even in the southern summer at the moon's only 4 or 5 degrees off the surface. So there's a lot of discussion about how would a crew member interact with the vehicle in a low lighting condition. And they saw some of that in Apollo. They landed early in the morning. So he had a lot of practical experience in that. Workload, you get tired in a spacesuit. So How do you operate a vehicle like this and make sure that the energy reserves you have, you are preserving for safety and also to accomplish the mission, and you're not working harder than you need to do simple tasks. So simple things like, hey, here's an armrest, for the controller. You need to move it forward, or it needs to be on a slider so that you can adjust it. I wouldn't have thought about that because I've never driven a car on the moon.
One other challenge that all of these LTVs will have to grapple with is power. A requirement from NASA is that the rovers be able to operate for at least a decade on the moon, and operations need to persist both with and without astronauts in the loop.
At the south pole of the moon, power is the dominant commodity you have to work with because
Power at night or just power overall?
power management, right? You need a lot of power, but if you have a lot of power, now you've got a lot of thermal waste heat. Where does that thermal waste heat go? So when the sun's up, you want to get rid of waste heat. When the sun's down, you want to conserve waste heat. So everything we do on the lunar surface is dominated by power, whether it's a rover or a science experiment or a human in a spacesuit. That power management is the essential, fundamental thing for mission success. So we've really worked on how do we get the right amount of battery storage? How do we make the batteries safe for the astronauts in all conditions? How do we make them durable over multiple discharges? How do we charge them fast, right? How do we replace them? That whole architecture, and it's more than just the batteries, it's the whole power distribution, power generation. Everything on this vehicle touches back to power one way or the other.
The thermal design for a vehicle on the lunar surface is critical, and that's another great example of where Lunar Voyage 1 came in. It gave us that opportunity to test and evaluate all methods of active thermal control systems, materials, things of that nature. And so all of the learnings from that have been applied to the lunar terrain vehicle and has resulted in this vehicle that can survive for a very long time on the lunar surface, explore deep into very cold, shadowed PSRs, and survive and operate during the lunar night.
The temperature swing is about 400 degrees C, and you can actually experience that swing from one side of the rover to the other, from sun-facing side to shadowed area of the rover. Thermal management is really the critical problem to solve. The way we are surviving the night is basically hunkering down. We can close our array, which has insulation on the backside of it. We can tuck in the wheels even. Imagine bundling up, right, in a sleeping bag almost. And we use our tremendous amount of energy storage on board. We have a lot of battery capacity, the equivalent of a modern electric vehicle and that capacity is used to keep all the subsystems above survival temperature, as we pass through the night. So interestingly, even though LTV can drive 15 kilometers an hour and the astronauts can, drive it like they stole it, that isn't really the driving requirement for the batteries. It's actually the hibernation period where we're doing absolutely nothing other than just staying warm.
Each of the companies and their teams spent the past year refining their designs and working to make themselves stand out from the competition. Part of that is leveraging learning from past and future missions. For Intuitive Machines, that included launching 2 of its Nova Sea landers to the moon over the past 2 years.
We had a design review with NASA, and they were asking questions like, hey, how do you handle this on the South Pole? What is your design to do to accommodate this? And to be able to answer it, well, 2 weeks ago when I was on the South Pole of the moon with our lander, this is what we did. It was a rich conversation that really validated the investment of other things we were doing into making this a very successful development. The other thing that's interesting is we have the delivery service, we have the rover, we have operations, and we have communications, all within our team. And so we're really able to look at the comprehensive solution to say, yeah, it's a rover, but it has a lot of support infrastructure to get it to the moon, to offload it from the lander so that it can operate, to communicate with it, to chart its course on the surface. We have a lot of practical experience now in those support areas that when we started, we knew were in front of us, but we hadn't done yet. So it's been a great year on this project, and then the influence of other things we're doing, communications and landers as well.
For Astrolab, it's pulling from its forthcoming Flip rover, which will launch on Astrobotic's Griffin lander at the end of the year.
We've actually raised the TRL of many of the core subsystems on the rover. So our tires, for example, are extremely capable. We just completed a 2-year test campaign of those, demonstrating that they survive thousands of kilometers in relevant environments. And we've built full-scale wheel actuators as well and tested those. Some of those elements are going into our rover this year, Flip. It's going to the moon in December of this year. And the cool thing about that mission is it's at the scale that we're able to test the full-scale subsystems. So we're testing full-scale battery modules, full-scale wheel actuators, full-scale tires that will all, ultimately end up on LTV.
And for Lunar Outpost, it's the work done on its MAP rover that flew as a passenger on Intuitive Machines' second Nova C lander.
Well, there's really no replacement for testing things in space. And so our MAP rover flying on the Lunar Voyage 1 mission gave us an opportunity to, prototype, test, and validate and achieve Lunar Technology Readiness Level 9, TRL 9, on a whole host of critical systems, all of which feed into the Lunar Terrain Vehicle. A great example would be our Stargate command and control software interface. So that commanded the MAP rover on Lunar Voyage 1 flawlessly, had very high uptime, exceeding the requirements for a Class A crewed mission like LTV. And so, that experience gave our Stargate system Lunar TRL 9. So it's now ready to operate the LTV on the lunar surface.
Each of the three designs are strikingly different from one another. From using NASA's Lunar Lighting Lab to help create the best lighting environment, to creating robotic arms to help with exploration, to the unique ways that the vehicles will actually move on the lunar surface. As of now, NASA says it only has the budget to select one of these. So, naturally, we wanted to know what each company plans to do if it's not them.
Lunar Outpost is really the leader in planetary mobility and robotics. And so we want to be providing mobility as a surface on the moon and beyond, in a wide range to meet all kinds of customer needs. So certainly we want to make sure that NASA and our NASA astronauts are well taken care of, but we have a wide range of commercial customers as well. And so the LTV and other platforms in development are designed to serve those customer needs from now into the future.
Well, we think this is a great platform that we can adjust in a variety of ways, crewed or uncrewed. So we would absolutely look at leveraging what we have and finding other opportunities. And, there's a young commercial market, but we would go after some science objectives. We would provide an alternative. The lander, the Nova D lander, that's important in our strategic development, whether this is the payload or not. And so we'll continue to develop our cargo class lander, which is the natural evolution of the technologies we've been perfecting with our Nova C lander. So the show will go on. You compete. You have to have courage to know you may not win everything. And then if we don't, we'll gather the team and we'll figure out what the next steps are. But the great thing about a focused technology development effort like this, the process of putting this together, we've learned a lot about what all the teammates can do. We've advanced technologies that we can use in other areas, not just LTV. And so we'll regroup and we'll get the team together and we'll say, all right, what's next? And I think there's some great opportunities that will come then as well.
On the immediate horizon, we have our first mission to the moon, FLIP, which FLIP stands for the Flex Lunar Innovation Platform. So the whole idea with it is it's a test bed for some of the critical subsystems. And so we're really excited to get that on the moon with Astrobotic later this year. One of the goals of that mission is to actually demonstrate surviving the lunar night. And so we hope to have success there at the end of the year. Beyond that, we also have separately already signed a launch contract with SpaceX to take a commercial Flex to the moon as soon as the end of 2026. So we've signed up a number of customers for that mission. Win or lose on LTV, we're going to carry forward with that mission as well. I think the lunar economy, I think, is an enormous opportunity, and there's room for a lot of players and a lot of ways to create value. And so, even if we don't move forward in LTV, I think we still have a role to play there.
Later this year, NASA will make its final determination on which rover will be selected to receive a task order for a mission ahead of Artemis 5. But since the majority of us won't be in the room where that decision happens, we wanted to have the companies each give the audience their 30-second elevator pitch as to why their lunar terrain vehicle should be the winner.
We're going to offer the best price, and we have the most comprehensive team for really building a rover that understands human spaceflight, lunar operations, South Pole conditions, the delivery, and communications. So we are the total package. You should absolutely choose us to win the LTV competition.
Well, the Lunar Dawn team surely is the most capable. I mean, with our excellent partners, General Motors, Goodyear, Leidos Dynetics, and MDA Space, we bring decades of crewed robotics experience, the might of the automotive industry sector, world-class tire technologies for our vehicles, and excellent human safety experience as well. All of that together in a package that delivers very quickly, makes great progress, and is very safe, reliable, and prioritizes NASA's science needs.
Well, Flex is the most versatile and most capable of the offerings, I believe. We've designed it from the ground up to have a lot of modular capability, and that modular capability allows us to add and take away elements, payloads, instruments, such that we can such that we can serve a wide array of customers and use cases. So we really think that versatility is key, particularly to serving as a catalyst for the lunar economy. That's ultimately our objective. We want to help as many people as we can be successful on the lunar surface, and ultimately have NASA be one customer among many.
And may the best lunar terrain vehicle win. Reporting from Space Symposium in Colorado, Will Robinson Smith for Spaceflight Now.